All right, so let's do one last example on these PQ vectors. In example 1.1.6, I'm given a point P and I'm given a point Q in R4. They have 4 components. I want to find the vector PQ. So what we just looked at is that PQ is OQ minus OP, and in my mind, I mean, it's not quite correct to write it down, but you think of Q minus P. So I'm going to take the components of Q and subtract the ones from P. So Q is 2 minus 5, 3, 10, and P is 1, 3, 2, minus 5. Notice that I like using vertical vectors for this. The corresponding component end up right next to each other, which makes it really nice. So I get the vector 1 minus 8, 115. That's my answer. All right, let's try the next one. In this case, I'm given 1 point, P, and I'm given the vector PQ, and I want to find the coordinates for Q. So here's my P, and I have PQ here, and I want to get Q. So I'm going to use, to make it real proper, I'm going to use the vectors OP, and I'm going to use the vector OQ. All right, so from what we saw over here, from the triangle that we have, we know that OQ is the vector OP plus the vector PQ. OP is the vector with the same components as P, so that's 1, 0, 5, and the vector PQ we were given minus 3, 5, minus 13. So in total, I get minus 2, 5, minus 8. So it looks like we're done because we have a nice answer. The issue is this answer, I'm sorry, I just wanted it to be a bit nicer. This answer is a vector. We want the point, but the point has the same component, and so it's minus 2, 5, minus 8. That's point Q. Now, just before stop this video, let me just show you something. We know that PQ is Q minus P in some sense. And so if you want to get Q, you start at P and you add PQ. Again, with quotation mark, because it's slightly cheating. We're not adding points and vectors. We haven't defined such an operation. So here you start at P, you add PQ, and you get to Q. In your mind, you can think that way, but make sure what you write is proper. Make sure you use those position vectors.